plus 1. That's equal to 56. Then we can solve that, yeah? So this gives us x squared plus x minus 56 equals to 0. How should we solve this? I think we should solve this with factoring. I don't think this is a problem for completing the square. I don't think this is a problem for the quadratic formula. This is a problem for our first line of defense, which is factoring. So x minus 7, x minus 8 will do it. Wait a minute. One of those got to be a plus, yeah? Huh. Where do I need to put the plus? Plus here, right? Okay, so this says either what? X equals to x is equal to 7 or x is equal to minus 8, right? And check it out. There's the answer that you guys guessed, right? Which was x plus 1 is what? 8. Or x plus 1 is what? Minus 7, right? So there are actually two answers. 56 is 7 times 8, but it's also minus 7 times minus 8, right? Those are also the product of consecutive integers. I didn't say positive integers in this problem, so there are two answers actually. Now I don't know. Okay, good. Yeah, your book gives that as one of the possible answers. It's multiple choice. So that's the neat thing, by the way. If we set up a problem algebraically correctly, it will find not just the answer that we could guess, it will find all possible answers. It's one of the really neat things about mathematics is it does this for us. All right, so I think next up here. So most of the other problems have some sort of geometric flair to them. Example 20. Here we're looking at the area of a rectangular wall of a barn is 252 square feet. Okay, so I'll draw a picture. Here's a wall of the barn, all right? And it's got 252 square feet. That's the area of this wall. The length is 10 feet longer than the width. So the length and the width, all right? And what's the relation? It says that the length is equal to the width plus 10 feet. All right? Wait a minute, excuse me. It's 10 feet longer than, I misread it. It's 10 feet longer than twice its width. So if it's 10 feet longer than twice its width, we don't put a W here, we put what? 2W plus 10. So this is length is 10 feet longer than twice its width. That sentence in the statement of the problem translates into that equation, right? 2W plus 10 is equal to L. Now we're supposed to find the length and the width of the barn. How do I do this? So what equations do? How about area? Area is length times width, right? We also know that that's equal to, in this problem, 252. But what do we know? Oh, we know that L is 2W plus 10, right? So I can substitute this right here, right, in to eliminate this L right here. I'm going to keep writing it over here. So what we have is 2W plus 10 times W equals to 252. Can we solve that? I mean, I hope so. Let's put it in standard form, see if we can see what we're dealing with here. We got 2W squared plus 10W, oh, excuse me, yeah, plus 10W minus 252 equal to 0. So everything's even. Why don't we just divide by 2 to make our life easier? Yeah? So this is w squared plus 5w minus 126. It's funny. Can anybody factor that? It feels wrong to me. I don't see the answer. Yeah?
No, I was just saying I don't think we can factor it.
Yeah. I feel like I've made an arithmetic mistake here. I don't know where. The length is 10 feet longer than twice its width.
Can you just take like the W out to like factor it?
Would it be 9 and 14?
Yeah, 9 and 14 is the 126.
9 and 14?
Yeah.
Oh, okay. So, this factors actually. I'm a dummy. Oh, so minus 9 or plus 14 and...
Plus 14 minus 9.
Yay. Now, if you didn't see that, quadratic formula wouldn't be a bad path here, right? Or completing the square, right? In a word problem, you're not really pinned down. You can use whatever technique you like the most, you know? I like it when students factor it for me. Thank you. So this gives me w equals to minus 14 and, or w what? W equals to 9. I was looking at the answer key, okay? And the answer key was telling me 9 and 28. And I was like, what? And I forgot. The answer is not what? The answer is not, this is the width, right? Which one of these is physical? The physical answer here obviously is this one, right? So we have the width is 9 feet. What does that make the length? 2w plus 10, right? Which is 18 plus 10, which is 28. Now both of these are in feet, right? So 9 feet and 28 feet, those are the dimensions of the wall. Right. So sorry, I got hung up on the factoring there for a second. See, factoring is, it doesn't matter how much math you do there. It's just sometimes factoring just will get you. Even when it's relatively not that hard, this problem, right? I mean, the factoring was whole number. It wasn't even fractions, and it still stumped me for a minute, you know? I think I have a pretty good number sense, but okay, moving on here. All right, so you got a rug, all right? And the rug is 21 foot. Well, no, you have a room. The room is 21 foot by 27 foot, okay? And she wants to, the person who's putting this carpet here, she can afford to buy 187, well, that's random, 187 square feet of carpet, all right? And she wants to make this carpet such that it has a uniform border in this room. So the carpet's going to look something like this, all right? So this is the, you know, uniform strip around the carpet, okay? And I said 187 square feet of carpet. All right, the question then is, what are the dimensions of the rug? What's the length and the width of the rug? So what's the question here really? The question really is, what's the thickness of the strip, right? Like if we could figure that out, we could solve the problem. So what I would do to solve this is I would call this distance right here, I would call this x, you know? It's also the same as this distance here, right? And what's the area of the strip? Let me kind of like shade in two pieces that are easy to think about. We've got this piece right here, right? And the same over here. What's the area of this piece that I'm shading? It's x wide, right? And it's 21 tall. So it's 21x for each one of those. So we've got a total of 42x from these two strips, right? But then there's also what's left, right? There's this piece right here. What's this distance? See, this here is x, right? This here is x. So that distance is what? It's 27 minus 2x. And so we have plus 2x times 27 minus 2x. That's the area of the horizontal piece. See, because I have x times 27 minus 2x, that's the height and the width of those strips, right? So that's the area of the strip. What does that have to be equal to? Think about it. What's the total area of the room? So it should be total, total area, right? Minus area of rug. So the total area would be 27 times 21. 20, oh, you're telling me the answer. 21 times 27. That's 567. And minus 187. And you said that was what? 380. I'll allow it. Aha! This is a quadratic equation, isn't it? So we've got, if you multiply this out, we have minus 4x squared. I've got 2 times 27, which is 54, I believe. 54 plus 42 is what? Plus 96x. And then minus 380, yeah? You can divide that by minus 4 to make it nicer. X squared, what's 96 over 4? 24. So x squared minus 24x, 380 divided by 4, divided by minus 4 is plus 95. And I'm going to complete the square on this one because it's got a nice, if I've got an even number here, completing the square is easy. See, this is x minus 12, quantity squared, minus 144 plus 95 equals to 0, which gives me x minus 12 quantity squared equals to 144 minus 95. What's 144 minus 95?
49.
Hey, 49, that's a nice number. Square root property gives me x minus 12 equals plus or minus the square root of 49, also known as plus or minus 7. Answers, x equals to 12 plus or minus 7. So we get x equal to 19. Right? Or what? X equal to 12 minus 7, which is 5. Search your heart. Which one of these is correct? Think about it. If you're cutting off 19 feet here, and you're cutting off 19 feet here, can you do it? You can't do it, right? It must be that x is, so this is an extraneous solution. 5, we want a strip of length 5. And you can figure out the dimensions of the rug once you know that, right? You can go back and, yeah. So like it's 27 minus, it's like 17 by, let's see the other, 17, this width right here is what? 21 minus 2x, yeah? So I think the dimensions we want would be 17 by 11. That's the answer for this one. Anyway, that's it for today. Listen, next time we'll maybe do a couple more of these. Any questions you have? And then we're going to be moving on to how to solve radical equations, okay, those involving square roots and cube roots and all that jazz. So, thanks guys.